Okay, confidence intervals worksheet answer key. So for number one, we're looking at a consumer advocate agency wants to estimate the mean repair costs of a washing machine. As part of the study, you select 40 repair costs, so N is 40, and you find the sample mean to be 100. And from past studies, you assume that the population standard deviation is 17.5. We want to construct a 95% confidence interval around this. So if you recall from reading the Z chart for confidence intervals practice session, that the 90% level of confidence is a Z value of 1.65. All right, so let's build the confidence interval. So we have 100, our sample mean, plus or minus Z, the 1.65, times sigma over the square root of n. So again, remember this section here, 1.65 times the standard deviation over the square root of n. Remember that whole area is called the margin of error. So we want to find what the margin of error is, and we have 100 plus or minus 4.57. Okay, so let's rewrite this as a range, and the range is 95.43 to 104.57. Okay, so that is our 90% confidence interval. Okay, for part B, we're looking for the 95% confidence interval. And again, recall from our lecture on Z confidence intervals that the Z value for 95% is equal to 1.96. Okay, so the confidence interval is 100 plus or minus 1.96 times 1750 over the square root of 40. Solving for the margin of error, we get 100 plus or minus 5.42. The range is 94.58 through 105.42. Just notice briefly that the range of our initial 90% confidence interval is going to be smaller than this range here for our 95% confidence interval. All right, now on to the 99% confidence interval. So using the Z value for 99% is 2.58 as we explained before. So we do 100 plus or minus 2.58 times 1750 over the square root of 40. And we find that the margin of error is 7.14. So the range in this case is 92.86 through 107.14. Notice, as the confidence level increases, the range or the confidence interval also increases. So here it asks us to draw the three intervals from the previous parts on a number line. So let's create that number line. Okay, so here's our number line. Okay, we'll start here right in the middle. We'll have 100, our sample mean. Our largest interval, the 99%, goes from 92.86 through 107.14. The 95% confidence interval goes from 94.58 through 105.42. And the 90% will be even smaller than that. For an overview of how to find the different Z values, the 1.65, 1.96, 2.58, please refer to the video for finding the Z value for a confidence interval posted a few days ago. Question 2. A publisher wants to estimate the mean length of time in minutes all adults spend reading newspapers. To determine this estimate, the publisher wants to take a random sample of 15 people and obtains the following results. So these are all the different reading times of these specific set of 15 people. And basically in this case, notice we're not given a mean or standard deviation. So we will be using this data to estimate our x bar, or find x bar, the mean, and also we will be finding the sample standard deviation. Therefore, in this case, we will be using a t-distribution. Okay, so first off, we need to find x bar. X bar is just the sum of all of those values divided by 15, and in this case, x bar is 9.07. Also, when you find the standard deviation of these values, again, you can follow the specific equation we've seen before, which is the sum of x minus x bar squared divided by n minus 1. We get a standard deviation of 1.58. Okay, so next we're going to construct a confidence interval for a mean population length reading time and interpret it. So first, what do we need? We need to know that x bar is 9.07. For our confidence interval, remember, we need a t statistic. And t, remember, is defined by the degrees of freedom and our level of confidence. So in this case, the degrees of freedom is equal to 14, which is n minus 1 or 15 minus 1, and the confidence level is 95%. So if you want some more help reading the t-table for confidence intervals, please refer to the lecture on reading the t-table. So confidence level 95%, degrees of freedom 14, gives us a t statistic or t value of 2.131. Then of course we multiply that by our standard deviation over the square root of n. So what is the margin of error in this case? Well, the margin of error is going to be 9.07 plus or minus 0.869. So how can we reduce the margin of error? Well, there's two specific techniques that we can use to do that. The first is to increase the sample size. And the second would be to reduce the confidence level. So here we're given an actual confidence interval and asked to figure out the sample mean, the margin of error, and the standard deviation. The sample mean is in fact fairly simple because it is the midpoint of the confidence interval. So all we'd have to do is add 34.5 plus 47.2, divide them by 2 to get their midpoint, which is in fact the mean, and that is going to be 40.85. This is our x bar. Now, the margin of error, okay, maybe a little bit trickier, but in fact, all we do is take, let's say, the upper range of our interval, 47.2, subtract our mean, and we get 6.35 as the margin of error. The standard deviation, okay, requires maybe one further step. What do we know? We know that after the plus or minus in the confidence interval equation, we have the margin of error. And we know the margin of error is equal to z times sigma over the square root of n. Well, we need to find sigma. This is what we're looking for. But we have all of the other pieces, so let's fill them in. So our margin of error is 6.35. And we set it equal to z, and the z of 90% is 1.65 times sigma, which is our unknown, over the square root of 100, which in fact is 10. Once we do a few little pieces of algebra, what we find is that the standard deviation is equal to 38.48. Okay, so just remember, any range that you're given, even if I give you numbers like this, 5 and say 15, and I said, well, what is the mean of this range? You would just take 5 plus 15 and divide by 2. In this case, 20 divided by 2, or 10. It's purely the midpoint. To get the margin of error is found by taking, say, let's take the upper range of our confidence interval. We take 15 minus the mean, and we get 5, which in fact is the margin of error of this question. Okay, number 4, we're doing a 2-day study on body temperature where 106 temperatures were taken. Suppose that we only have the first 10 temperatures, so n is 10. The mean and standard deviation of these specific 10 scores is 98.44 and 0.3 degrees for the sample standard deviation. We want to construct a 95% confidence interval. So in this case, we're going to be using a t-distribution. Why? Well, because we don't know the population standard deviation, however, we do have the sample standard deviation S, or 0.3. So let's set this up. N is equal to 10. Degrees of freedom in this case, or n minus 1, are equal to 9. X bar is equal to 98.44. And S is equal to 0.3. And we're looking for a confidence level of 95%. Now let's set up our interval. So we have 98.44 plus or minus the t value in this case, based on the 95% level and 9 degrees of freedom, is 2.262. Once again, if you have any trouble, please refer to the lecture on finding confidence levels for t-distributions. And we multiply that by 0.3 over the square root of 10. And we get the following: 98.44 plus or minus a margin of error of 0.214. Okay, question 5. In a time use study, 20 randomly selected managers were found to have spent a mean time of 2.4 hours per day on paperwork. The standard deviation of the 20 scores was 1.3 hours. Construct a 98% confidence interval for the mean time spent by all the managers. Once again, we're using a t-distribution because we only have sample data. And in this case, what do we know about our t-distribution is that our degrees of freedom are 19 and our confidence level is to be 98%. All right, so let's set up our confidence interval. So we have 2.4 hours plus or minus our t value, which is 2.539, times 1.3 over the square root of 20. So 2.4 plus or minus 0.74 as the margin of error. And this is our 98% confidence interval. Okay, number 6. We're looking at proportions in this case. So we have a sample size of 1,016, and we're talking about people and their pets. And it says of those surveyed, 599 said they had at least a dog or a cat as a pet. We want to construct a 90% confidence interval and find what is the margin of error. So we have our sample proportion, which is P, which is 599 over 1,016, and this is equal to 0.59. So the confidence interval is P, 0.59 plus or minus the Z value for 90% confidence interval, which is 1.65, times the square root of 0.59, 1 minus 0.59 over 1,016. The margin of error in this case is 0.59 plus or minus 0.025. Okay, next one. Now we want to create the same thing but a 99% confidence interval. So 0.59 plus or minus 2.58 times the square root of 0.59, 1 minus 0.59 over 1016. And in this case, our interval becomes 0.59 plus or minus 0.0398. Okay, number 7. A random sample of 19 women, so n is 19, results in a mean height of 63.85. So there's our x bar. Other studies have shown that women's heights are normally distributed with a standard deviation of 2.5 inches. Construct a 90% confidence interval. So here we're using a z-score because this standard deviation here, based on previous studies, is in fact a population standard deviation. So let's set up our confidence interval. So we have 63.85 plus or minus z of 90% is 1.65 times 2.5 over the square root of 19. And so we get 63.85 plus or minus a margin of error of 0.95. Okay, number 8. Health insurers and federal government are both putting pressure on hospitals to shorten the average length of stay. A random sample of 27 hospitals in one state had a mean length of stay of 3.8 days and a standard deviation of 1.2. Construct a 98% confidence interval. So in this case, this 1.2 days, the standard deviation is a sample based on the 27 that we started with. So we're going to need to use a t statistic or a t-test. So let's set up our confidence band. So we have 3.8 plus or minus t-score for degrees of freedom of 26 and confidence level of 98% is 2.479. And we multiply that by our sample standard deviation divided by the square root of our sample size. Our margin of error is going to be 0.573. Keep in mind in your homework, it is also a good idea to fill in the range. So you would add 3.8 plus 0.573, or you take 3.8 minus 0.573 in order to get that range. All right, so last question here. We have Tool and Die has 293 offices around the world. Here we have taken a random sample of 6. So this is the 6 observations. And we need to use this to find the mean standard deviation and generate a 95% confidence interval. First, we have n being equal to 6, which means our degrees of freedom are equal to 5. And we're using a t-distribution here because we're going to be the ones calculating the sample standard deviation, as it is clearly, the population standard deviation is clearly unknown. So in this case, when we add all these numbers up and divide by n, we get an x bar equal to 985.5 and a standard deviation of 115.497. All right, so let's create our confidence interval. So we have 985.5 plus or minus the t for 95% and degrees of freedom of 5, which is 2.571, times our sample standard deviation over the square root of 6, which is our sample size. And we find that we have a confidence interval of 985 plus or minus 121.23, or a range that ranges from 864.27 to 1006.73. Please feel free to comment on this video with questions or issues. I will gladly address them.